Welcome back to another Gungahlin College Maths Applications video lecture. The topic of this lecture is going to be solving matrix equations. So what exactly do I mean by solving matrix equations? I think to start off with, I want to start with something you guys are really familiar with. So let's start with regular algebra. We're solving a regular equation. So if I were to give you an equation like ax equals b, right, where a is just a number that you know, and b is just a number that you know, and x is an unknown, you know how to solve this. So if I gave you a, x is equal to b, you would know that to solve this, you need, when I say solve, it means to get x on its own, right? So we need to divide both sides by a. And this will give you x is equal to b divided by a. So another way of doing exactly the same thing would be to, instead of dividing by a, take ax is equal to b, and instead of dividing by a, multiply by 1 over a. Or as we said in the last lecture, multiply by the multiplicative inverse of a. So I could do that to both sides, and what I would get is exactly the same thing. So multiplying by 1 over a undoes multiplying by a, so that just leaves us with x is equal to b times 1 over a, which is the same thing as b over a, which is also the same thing as b divided by a. So we arrive at the same thing doing it either way. Okay, that's regular algebra. So now what I want to do is talk about matrix algebra. So matrix algebra is actually quite similar in a lot of ways to the algebra that you're used to. So the same kind of equation that you might be given would be to have a matrix A times another unknown matrix X is equal to another matrix B. And you might be asked to solve this. So again, this is a known matrix. This is a known matrix. And this is your unknown matrix. So if somebody were to ask you to solve this equation, you would be trying to get this matrix on its own. So just to make this really clear, let me write out this as an example. So for instance, if we had the matrix A equal to 3, 1, 7, 2, B, our other known matrix, equal to 7, 15, and our matrix X equal to, again, this is unknown, right? So we're going to use pronumerals in this matrix, right? This is a completely valid matrix equation that someone could give you. So you could be asked to solve this. So solving for x. So if somebody said solve ax equals b, how would we actually go about doing this? So exactly the same way as for regular algebra, actually. So instead of dividing by a, right, we don't have a way to divide by a matrix, but we do have a way of multiplying both sides by the inverse matrix. So because matrix multiplication doesn't commute, so we have to be very careful with the order here on the left-hand side. So in order to get rid of this a, we actually have to multiply on the left-hand side by the inverse of a. So I can multiply both sides by the inverse of a. Right? So all I've done here is said I've taken this equation and I'm multiplying both sides of it by the inverse of a, exactly like before when it was just regular algebra. I multiplied by 1 over a. So if I do this, a inverse times a should just give me the identity matrix times x is equal to a inverse times b. So this is x is equal to a inverse times b. So we know how to find the inverse of a, and we already know b. So what we've really done is actually solved for our unknown matrix x. So why don't we go ahead and work out an example. Let's work on this example up here actually. So let's do the example ax plus b, not ax plus b, ax equals b, where a equals 3, 1, 7, 2, and b equals 7, 15. Okay, so we've already actually solved for it up here. So we've done the hard work really. All I need to do now is we know that x equals a inverse times b. So what I need to do is work out the inverse of a and multiply by b. So let's work out what the inverse of a is. So we're going to do this exactly the same way we did it in the last video. So the inverse of a is 1 over the determinant of a, which is a times d, 3 times 2, minus b times c, which is 1 times 7, times the matrix where we switch these two numbers around. So we're going to go 2 here, 3 here, and negative of those two numbers. So negative 1, negative 7. Okay, so now we can simplify this. 1 over 6 minus 7, so 6 minus 7 is negative 1, so this is going to be 1 over negative 1 times 2, negative 1, negative 7, 3. 1 over negative 1 is just negative 1, so I can multiply everything in this matrix by negative 1 to get our inverse matrix. So 2 times negative 1 is negative 2. Negative 1 times negative 1 is 1. Negative 7 times negative 1 is 7. 3 times negative 1 is negative 3. And that's it. That's our inverse of a. So now to find our unknown x, right? We said x is a inverse times b. So that's negative 2, 1, 7, negative 3 times b, and just scrolling back up here, b was 7, 15. Okay, so again, we're going to do matrix multiplication exactly like we've done it before. So we're going to do it fairly quickly. Minus 2 times 7 is negative 14. 1 plus 15 is 15, so 15 minus 14 is 1. 7 times 7 is 49. 49 minus 3 times 15, so 3 times 15 is 45. 49 minus 45 is 4. So that's it. We've actually solved our first matrix equation. X is equal to 1, 4. Now if you wanted to, you could actually take this matrix here, this 1, 4, go back up here and multiply it by A on the right hand side, right? So A times this 1, 4 matrix, and check and make sure that it's equal to B. So you can always check your work just like you do in regular algebra. Okay. So now what I want to do is just work out one more example really quickly. So let's do another example with different sizes. So let's say again I've got A, and actually what I'm going to do is multiply it on the other side. So I'm going to do x times A equals B. Because remember, this isn't the same thing as A times x, right? I can have matrix equations where I have x times A or A times x. So I'm going to do x times A is equal to B, where A is equal to 3634, and B is 275, negative 1. Okay. So let's look at this equation over here. So x times A is equal to B. So if I want to get x on its own, what I really need to do is multiply both sides of this equation by the inverse of A, but I need to do it on the right-hand side. So in other words, I need to do x times A, right, on the right-hand side, multiply by A inverse. So times A inverse equals to, and it's again on the right-hand side over here too, so B times A inverse. Right, so I'm multiplying both sides on the right-hand side by A inverse. So we can simplify this, right? X times A inverse. So A times A inverse is the identity matrix. So this is X times the identity matrix is equal to B times A inverse. X times the identity matrix is just X. So X is equal to B times A inverse. So the only thing that's changed from the last example that we did is instead of B times A inverse, the solution is now, instead of A inverse times B, the solution is now B times A inverse. B times A inverse. So in order to solve this, all I need to do is again find the this was 3. Find the inverse of A and multiply B on the right hand side by the inverse of A. So let's do that. So let's first of all find the inverse of A. So it's 1 over the determinant, so 1 over A times D, so that number times that number, 3 times 4, minus B times C, so 6 times 3. 3 times 4 minus 6 times 3 times the matrix. Remember, we switch these numbers around, so 4, 3, negative 6, negative 3. So that's A inverse. And remember, I said my solution for x is B times A inverse. So I'm going to take B A inverse. B A inverse is 2, 7, 5, negative 1 times A inverse. I didn't actually simplify this, but 3 times 4 is 12. 6 times 3 is 18. So 12 minus 18 is negative 6. So I'm going to have 1 over negative 6 here times this matrix 4, negative 6, negative 3, 3. So now all I need to do is do this matrix multiplication and we'll be finished. So to do this, I'm going to leave this out the front for now. Minus 1 divided by 6. Row 1 times column 1 is 8 minus 21. 8 minus 21 is negative 13. Row 1 times column 2 is 2 times negative 6 is negative 12. Negative 12 plus 7 times 3 is 21. So negative 12 plus 21 is positive 9. Row 2, column 1. Row 2 times column 1. 5 times 4 is 20. Plus negative 1 times negative 3 is positive 3, so that's 23. Row 2, column 2 is 5 times negative 6 is negative 30, plus negative 1 times 3 is negative 3, so this is negative 33. So that's it. All I need to do now is simplify. So I can multiply everything in here by this scalar at the front. So that's going to be negative 13 divided by negative 6 is 13/6, which I can't simplify any further. 9 divided by negative 6, I can, but we'll do that later. So negative 9 divided by 6. 23 divided by negative 6 is negative 23 divided by 6. Negative 33 divided by negative 6 is just 33 divided by 6. So we can simplify this out. 13 divided by 6 we can't simplify. Negative 9 divided by 6 is a negative 3/2. You can check this yourself. Negative 23 divided by 6 we can't simplify. And 33 divided by 6 is 11 divided by 2. And that's as simple as we can get it at. So this is equal to x. And again, whenever you finish solving a matrix equation, you can always take your solution and plug it back in to your matrix equation and double check that you've gotten it correct. But that's all the examples for now. All right, I'll see you in class.